In this video, we're going to take a look at finding conditional probabilities using a tree diagram. For example, a police department sets up a sobriety checkpoint on a weekend. It is presumed that 12% of drivers have been drinking. The officers at the checkpoint make the correct choice of whether or not to detain drivers 80% of the time. What is the probability that a person who has not been drinking has been detained? First, let's set up our branches for drinking and not drinking. We know that 12% of drivers have likely been drinking, and we'll write that as a decimal. 88% of drivers have likely not been drinking, so we'll call that ND. Now, the police officers make the correct decision of whether or not to detain a driver 80% of the time. So if a person has been drinking, then obviously the correct choice is to detain them, and they would make that choice 80% of the time. However, 20% of the time, they might overlook, by mistake, the person's impairment, and so 20% of the time, that person who had been drinking would not be detained. Now, if a person has not been drinking, then the correct choice is to not detain that person, and that should happen 80% of the time, according to our information given. And if a person has not been drinking, then the wrong choice would be made 20% of the time, and that would be for a person who is not drinking to have been detained. Now, determining the probability that a person who has not been drinking has been detained is very simple. If we look at our tree diagram, given that a person has not been drinking, the probability that they are detained is this branch right here. So the answer would be 0.20 or 20%. Next, we would like to know what is the probability that any given driver will be detained. So, the probability that a person is not drinking and has been detained, 0.12 times 0.80, and we'll sum that or add it to the probability that someone has not been drinking and has been detained. That is 0.88 times 0.20. Working this out in a calculator, we get 0.272, or about 27.2%. Now, let's determine the probability that a person who is detained has been drinking. In other words, what we want to know is the probability of drinking given that they were detained. So what we do is we look at the probability that someone was drinking and has been detained. That is 0.12 times 0.80 divided by the sum of the probability that a person has been drinking and detained plus not drinking and detained. Working out this probability, drinking and detained divided by the sum of drinking and detained plus not drinking and detained gives us 0.353, or about 35.3%. Finally, let's determine the probability that a driver who was released had been drinking. So, in other words, the probability of drinking given that they were released. Or, to be consistent, we could say drinking given that they were not detained. So, the probability that a person who was stopped was drinking and not detained, it's 0.12 times 0.20 divided by the sum of 0.12 times 0.20 plus 0.88 times 0.80. This works out to be 0.033, or about 3.3%. This concludes our example of finding conditional probabilities using a tree diagram. I hope you found it helpful, and we'll see you next time.